Good morning to Boston, good afternoon to Barcelona and Bergheim. We are from the IT infrastructure team from Festo and would like to present an important topic for us and for you, why Kubernetes is indispensable for a modern IT infrastructure. My name is Sevket Avci. I am mainly taking care of the Linux topics and the Kubernetes topics for Festo. And I have my colleague Vincent Eberwein on the left side.
Hello from my side. My name is Vincent Eberwein. I'm also IT infrastructure specialist at Festo. I'm mainly working also with Sevket in the department Kubernetes and Docker. Our second pillar, the Linux server administration, and the third part also IT automation across the whole department, Windows, Linux, and basic infrastructure. So, Sevket, what we are gonna talk about today?
Yeah, a short look on our agenda. We will start with a brief introduction. Then I will talk about how our journey started with Kubernetes, and we will take a look how a conventional VM works and what's the difference to Kubernetes. Vincent will go on with some benefits of Kubernetes and Festo's use cases of Kubernetes, and at the end we will also have a showcase. IT applications are getting more and more complex. If you look at a software monolith, there are many teams working at a weekend to maintain a software. IT application operations teams, IT infrastructure teams, and this can go very smooth, but sometimes there are many changes, and this can also lead to problems. Using containers can reduce your complexity, but it can also reduce your downtime. On the other hand, Festo has also many software developers, and they don't want to waste their time with package installation and other stuff. Using containers is also a good possibility to reduce your complexity here and build a good working environment for them. So Kubernetes is an open source tool for container orchestration and was originally designed by Google in 2014. And you have some key advantages with Kubernetes. You can automate your software deployment and scale up and down your deployments. On the other side, the topic right sizing. Most of the IT applications which are running are actually using too much resources, and Kubernetes can help you to reduce these unneeded costs. And the last point, Kubernetes can deliver an always-on experience for your customer. You don't need any downtimes anymore for your application. Now, I will also take a look to the past, because we didn't say now we are doing Kubernetes. We had a little journey to that point. First of all, at Festo we started using single Docker hosts, and this took about 2 years. We had about 50 Docker instances at Festo, and then we saw, oh, we are having some not major issues, but we have some more work to do here. Because you have to maintain every single Docker host, you have to set up these Docker installations, and there are sometimes different Docker versions. So we decided then to use Kubernetes, and within a project team, we had a hackathon to look at different Kubernetes solutions. And at the end, we decided to use Kubernetes in the cloud. We will not go much into detail, but I think some basics are very important. On the left side, you have a conventional VM with some infrastructure at the bottom and a hypervisor. There is a running virtual machine on this hypervisor and then an application. On the right side, we have also the infrastructure, our operating system, then the container runtime, and you then have different applications managed by your container runtime.
Perfect. Now I want to start with the benefits of Kubernetes. What are the benefits this service orchestration platform is offering to you? But first of all, before I come to detail, I want to give you a basic overview about the architecture of Kubernetes. So on the left-hand side, we have the control plane, which is also called master nodes. On the right-hand side, we have worker nodes, and there are different components located. So on the worker nodes, also your workloads will be executed, which is then called in Kubernetes pods. So one pod could be one container, but of course one pod can also contain multiple containers. So when we start now on the control plane, you can see, for example, here's an API component. This is the main entrance to the cluster. So when you want to control the cluster, you will send some requests to the API server here, and then this will be executed. Then we have a scheduler component. This component is needed when you want to deploy some workloads in your cluster. Then the scheduler will have a look which worker nodes do its best for your workloads based on some metrics. And then your workload will be scheduled on one of the worker nodes. Then we have also the etcd. So this is a distributed key value store, which is persisting the data across all the master nodes. So these can also be multiple nodes for high availability scenarios. And all the configuration of the cluster is then stored in this key value store. Then we have also a controller manager. This is also a very major component for Kubernetes, so kind of a control loop which checks on a regular basis what happens within the cluster, and then reacts on some outages, will redeploy some applications for you or some workloads. So this is handled by the controller manager. And last but not least, on the control plane, we have also some or a cloud provider controller. So that is an optional component which you have to use when you go into the cloud and use some managed Kubernetes services here. It's also very important that you can communicate to the cloud provider API from within Kubernetes. So for example, you have some ingresses or some services from type load balancer. You can then from your cluster deploy AWS or Azure Load Balancer, for instance, directly from your Kubernetes configuration. When we have now a look to the worker nodes, there are two components located. The first one would be the kubelet. So this is a component which is kind of an agent which is connecting the worker nodes with the master nodes so that they have a communication. And then there's the second component, the kube proxy, which is used for networking on the worker nodes. So you can define some network rules here so that the pods and the single containers can communicate between each other. So this is the main infrastructure, how Kubernetes is structured and working. And now I want to give you some insights. What are the key benefits that Kubernetes is offering to you? So the first one would be resilience. So what does this mean in Kubernetes? For example, the first point, replication. You have a replication controller within your cluster. So when you deploy some workloads, this replication controller ensures that every time your specified replicas are running within the cluster. Also, when we look to the point here, self-healing, which means you have an automatic detection of outages and also faults within the cluster. So there are some liveness or readiness checks for your application. And as soon as the controller recognizes, oh, my application isn't responding here, the cluster will terminate the pod and redeploy it. Redeploy it. And the last point would be then also the fault tolerance of the Kubernetes cluster, which means for example, the API server is down, this does not mean that also your whole application is down. Then you cannot communicate with the cluster, but your application itself is running. So all the components I showed before are self-reliant here. That's a good point. Okay, so that was the first key benefit. Now the next one would be the automatic scaling. We can also subdivide it into 2 different points. We have first one, the cluster auto-scaling, and then we have also the horizontal pod auto-scaling. So when we speak about cluster auto-scaling, this means that we horizontally scale up the worker nodes. So based on your deployments, for example, you have a web shop, you launch a new product, you get very high traffic to your web shop, and probably if you have a Linux instance with 64 GB of RAM, this will be exhausted and your web shop will crash. So it could not happen, or could happen in Kubernetes, but should not. So when you have automatic auto-scaling, the cluster will measure the metrics of your deployments, and as soon as the cluster recognizes, oh, there are some more resources needed, the utilization is very high, then the cluster will go and deploy new worker nodes so that your application will run distributed on more nodes here. So that's the first point when we speak about horizontal auto-scaling on the node level. And the next point would be also the horizontal pod auto-scaling. So normally in Kubernetes, when you deploy your application, you need to know what are the requests or the resources your application will need, so you specify that in your deployment, and you can also specify some limits so that your application cannot use more than 20 GB of RAM, for example. And then you have a horizontal pod autoscaler within the cluster, which measures the metrics, and as soon there's a certain threshold triggered, for example, 80% of RAM are used, then the horizontal pod autoscaler will scale up the replicas of a single pod within the cluster, so that you have more replicas of a single application distributed across the worker nodes. That's the intention behind that. Yeah, the third point would be also cost efficiency. So you can run your workloads or deployments very cost efficient within Kubernetes. You have an efficient resource utilization, which means that only the resources which are really needed will be used in the cluster. So you have no many idle resources when you configure everything right, and also no severe over-provisioning of your applications, so that you have you pay only for that what you're actually using when you configure everything right. And the next point I want to mention is also the automated operation within the cluster. So that reduces a lot of manual interaction for you. So you do not need any other persons which check if is the application running. You have to scale it manually up, so everything is handled by Kubernetes itself. And as soon as there's a fault detected, Kubernetes will handle this process for you and heal the deployment. And the last benefit I want to address here is the zero downtime patching. So that's also very important from my point of view. So when we speak about applications that are very so how to say so you have a rolling update within the cluster. So that means that you have a gradual replacement of old pods with new ones while maintaining the application availability. So for example, you have a web application and there will be a new image deployed with a new version. Then you specify that in your deployment, a new pod will be scaled up. And as soon as this pod is running, the old one will be deprovisioned. And then you have a zero downtime patching, and the end user doesn't recognize that there was any update in the background with any outage here. Okay, so that's basically it about the key benefits. Now I want to give you some insights how Festo is using Kubernetes at the moment. First of all, our landscape here at Festo. So this is a basic overview about the things we are operating here. So we have some management tools in place on the left-hand side, and also the monitoring tools. And then we have our managed Kubernetes clusters we are offering from a global or infrastructure managed IT perspective. So we are focusing here on 2 cloud providers. This is on the one hand side Azure AKS, and then also AWS EKS. And we use the managed service of the cloud providers. And we'll take care about the whole lifecycle management, the Kubernetes updates, and you do not have to take care about that here. And then now the question would be how you can access these clusters, or how can you control them. So easy we have our Rancher application in place, so that's a management interface where you can interact with the cluster. It's like a web application with a nice graphical user interface. So also an easy login to Kubernetes if you are not that familiar with it. So you can specify everything in some formulas there, and then Rancher will build the deployment YAML files in the background for you. But of course, if you are more sophisticated, you can also use kubectl, so the command line tool for Kubernetes, and start deploying your applications with that tool. And yeah, we have also, of course, some monitoring tools in place which are provided from our side. This is on the one hand side Prometheus, so a time series database with a Grafana front end to visualize all the metrics. And since around about 1 month, we have also Elasticsearch instance where you can forward your logs of the containers, and you have a persistent history of all your logs of your containers. So that's the basic overview about how we operate that here at Festo. And Sevket, you now want to say something about some special applications.
Yep. Actually, we have over 50 applications on our Kubernetes clusters. We will just look into 2 to get in touch with the advantages of Kubernetes. So we have a vCam board. It's an open source board for teams, and actually it's also running on one of our Kubernetes clusters. And the cool thing is we have about 40 updates for this application, and nobody of our team members doesn't even notice that there is an update for that application. So we have to inform them that there is a new version or a new function so that they actually see that there is a new version. Another example, which is also running on our Kubernetes cluster, is the Jenkins from our software development colleagues. They are using Jenkins on the cluster very efficient. That means Jenkins, here are sitting many developers, so I don't have to explain Jenkins to you, but you have some times where Jenkins is using a lot of nodes and stuff, and this needs automatic scaling of the nodes. And there is also a lot of time where Jenkins doesn't use much resources, and in this time the cluster also reduces that nodes. So that's very cost efficient at that point. In the past we had these nodes on premise running all the time, and actually it's just scaling as our needs. Then, for the last point, we have our showcase, and Vincent will start to deploy our showcase, and we need also your help with our application. So get your mobile phones ready.
Exactly. But before we start the deployment, I will give a short overview about the architecture, about the distributed application we are deploying now. So as you can see here, so that's our perspective, the user in front of. The distributed application consists out of 5 containers. So there is a Python front end, which is a Flask application for voting. You have now then 2 possibilities to vote for 2 options here. This Python Flask application is writing the votes you are sending on the front end to a Redis queue. And then, of course, we have also a .NET worker, which is reading the votes from the Redis queue and writes it back to our Postgre database, which is our 4th container here. And last but not least, to display the results, we have a small Node.js application, also a front end, which will display in real time your votes when you then vote on your smartphones. So that's basically the overview about the application. So I would say now we start the deployment here. So. That sounds good. Yeah, perfect.
And for questions.
Okay, so that's a basic overview about the deployment file in Kubernetes. So it's a YAML syntax. Where you can specify everything. I will not explain everything here in detail. And we start immediately in regards to the time of the deployment. So I'm here on a Linux server, which is our management host, and I will apply the deployment files I already pre-configured here. So we have the test, and then we have to specify the namespace. And you can see here all our deployments and service files will be created. So we need also some services that the application is reachable. And I pre-configured also an ingress with a load balancer on AWS so that we have now public access. So I will now show you the QR code. So you can please scan that. So roundabout it took probably 5 seconds till the application is running. I will try that here on my own.
And the main question is, do you prefer a conventional VM, like in the past, or Kubernetes?
So I will here to the right side, and I will open the result page too, so that you can see immediately the results. So we have already 20 volts. It's quite promising here. So, it will be a closer race here. You can change it, right? Yeah. Perfect. So yeah, that's the main overview about our showcase here. So I will jump back to the presentation. That will be the last step. Come on, so the QR code again. And yeah, that was the last part of our presentation. So I would like to say thank you for your attention, and I hope we could provide you some insights how Kubernetes is working, what are the key benefits, and how we use it at Festo. And of course, if you have any questions, please raise them now. And yeah, if you want, you can stay connected and scan our badges here. Thank you very much.